This is Professor Darif Seitz. This Java tutorial is about nested loops. Nested loops is one loop that contains another loop inside it. We have a main function that calls several illustrative looping functions. The first one here, show iterations. We have a for loop with a loop control variable of I going from 1 to 10 by 1, up by 1 each time. And inside it, another for loop with a control variable of j going from 1 to 10 as well. And we just print out I and j inside the innermost loop. And we're keeping a count of how many times the innermost loop will be executed, and we'll print that out. So we have, for each iteration of the outer loop, the inner loop will go 10 times. So 10 times 10, 100 iterations of this innermost block. Notice the indentation with nested for loops here. We have for loops. You can nest a while loop and a for loop inside of it, or a for loop and a while loop. You can mix and match them. But here we have for loops. The brace is here, and then one indent level in. The brace is here for the for, and one indent level. It's very important that you maintain proper indentation for readability of your logic. The next for loop, well, not for loop, the next nested loop happens to be a for loop. Nested fors again. We're going to find the common characters in two strings. We have string 1 and string 2. They happen to be the alphabet from A to Z and the alphabet reversed from Z to A. Finding the common characters, the outer loop will go through string 1 starting at position 0. Strings characters are 0 relative, and it will go up short of the string length because it's 0 relative. It'll go through every character of string 1, and in the innermost loop it will compare that character to every character in string 2. And we see that after the control statement here, we get the character position I in string 1 and store it in char 1, a character, and then we go through this innermost on string 2, and then we're going to compare the character that we get from string 2 to the character in string 1, and if they're equal, we now have a common character, and we're going to build up a string adding to it character by character the common ones. And as soon as we get a common hit on their innermost, we don't need to continue at that point. It breaks out of the inner for here and goes back to the outer for, because we already know that we did have a common character, and we have that character captured. We're going to go on and look at the next character in our string 1 in the outermost loop. So the break statement here is a useful statement in a looping scenarios, and it will take you out of the current loop one level out, which in this case takes you back to the loop control statement of the outermost loop. And then we print out our results down here, our two strings, and also the common character string. Our next function is going to find the prime numbers up into a maximum. We're going to look for up through 100 here. We'll initialize an array to be max plus 1 size, because arrays are 0 relative, and we're going to initialize that array starting at 2. We don't really care about numbers less than 2 because primes start at 2. We'll just ignore those two spots in the array. If you don't understand arrays, that's okay. Concentrate on the nested fors that we'll be looking at here, and just kind of intuitively get a basic understanding of what the arrays are doing. It will help you understand them better when you do see them. But this first for loop here is not a nested for. It's just going through from position 2 in the array, which is the third entry because it's 0, 1, and 2, and initializing the array to the numbers that correspond to the indexes. So the array will have numbers in it, the first from 2 to 100, in the same index positions. Then we enter our nested for here. And the strategy is we're going to start with 2, we'll go up through our maximum, and we're going to look at what's in the position first. If it's not equal to a 0, then we have to take what's in there and start another loop with a control variable that will take our outermost control variable plus itself, and each time plus it by itself, so it's going to look at multiples of, for example, 2. It'll be 2 and then 4 and then 6 and then 8, and because they're multiples of the 2, we know they're not prime because that means they're divisible by the 2, and so whenever we hit one of those, we take its slot and set it equal to 0, which knocks it out essentially of when we go back through later, as it's no longer a candidate for a prime. But the first one we encountered, we don't do it for the first one, just the multiples of it. And then we're going to bump to 3 and find multiples of 3, the same technique, and to 4. There are more efficient little additions that can be added to this algorithm, but they're more complicated to understand, that use things like square roots or squares and things like that. We just did kind of a basic algorithm here, but it's still pretty slick how it's in such a small amount of code with a couple nested fors can find all the, or can indicate all the prime numbers there. So we're going to display them then by going through the array, and anything that's not a 0, we're going to print it out, and that'll be a prime number. Here we have a sort. We have an array of 9, 5. It's not sorted. We're going to have an outer and an inner for loop that are going to go through the array starting at a certain point and then find the smallest number and then swap it. Swap the smallest one with the first one, and then we'll go to what's called a tail, an unsorted tail, find the next smallest, swap it, move over, and just keep doing that, and we'll end up with the array being sorted. So the outermost goes through the array, the innermost goes through the tail and looks at a minimum, and when it does find something smaller in the tail, it keeps track of the index of where it is, and then when it's gone through the whole tail, it swaps the smallest element in the array with the start of that tail. And then we print out that array. Our last function to look at is a staircase function. It will print out a staircase with 10 steps. And we have an outer for loop that goes for the number of steps. And in the inner for loop, we're building up what those individual steps look like by putting equal sign characters, a certain number of them. And notice that the innermost for loop here, which uses j as the control variable, is using I as part of the expression of how far it will iterate. And this will be clear when we see the output of how this works. Alright, let's go to our output now. First we see the iterations where we're doing 100 different, so we have the outer loop variable, the inner loop variable. The inner one goes 10 times for every one of the outer, and you can see it goes all the way down to total of 100 iterations. Here we find the common characters between these two strings, alphabet and reversed alphabet, and it turns out that the common characters are all of them, the whole alphabet. The prime numbers from 2 to 100 are found through that algorithm using the nested for loops. We had a little sort algorithm, and it sorted out the little array of the 9 single-digit numbers that were not sorted. And finally, here's our staircase output that was output from that nested for structure staircase function. Let's go back to the program again. So we see a variety of quite powerful techniques here from these nested loops. And in our case we mainly used for loops, but it gives you, with a small amount of code, a large number of things that can happen because of the repetitive nature of them. And they're quite impressive that we can find the primes with a little algorithm like that. We can do a little sort quite efficiently. And the staircase, very small little code to print out that staircase. So nested loops are frequently needed to do complex repetition logic.